Now, I do apologize because I totally butchered up the numbers on this thing. So there's typos. Let's fix them before we even start, all right? So here are the typos. Notice we have 1, 2, 3, 1, 2, 3, 4, 5, and 6, 4, 5, and 6. But then right here, this should be 7 and 8, not 6 and 7. If this is 6, how this is going to be 6, right? So that's my first typo. Let's go right here and let's change this to not a 6, 7, but a 7, 8. This one's worth 2 points because you have to graph both inequalities, all right? So that's my first mistake, which means that all the other numbers are also incorrect. Let's go over here also and change this 6, 7 to a 7, 8. Change the next one, 8, 10. It should be a 9 through 11. And of course, on your answer sheets or your answer column, also you're going to need a 9 through 11. Instead of 11 through 13, it's going to be a 12 through 14. Instead of 14 through 16, it's going to be a 15 through 17. And then we do have a 18, 19, and 20 on the back side, but you know, an easy way to do this would just be to scratch out that 17. That way you have the 18, 19, and 20 already right there. Okay, so I apologize for that. My bad. Let's go through now and go over these questions. Now, I also noticed that I made a typo. I accidentally selected all of these 2x2 systems to be special cases. All right, I probably should have at least picked one where it's a nice answer. But let's just go through this. Question 1 on the test tomorrow will ask you to graph it and tell me the answer. So in order to graph, you need to make sure that both of them are in slope-intercept form. So that top equation, we have to rewrite this thing over here. And let's subtract 4x and subtract 4x. So our new equation, sorry, that's too small right there, is negative 2y equaling negative 4x minus 6. And then we'd have to divide everything by 2, by negative 2 that is, to get y by itself. And we will have y equaling positive 2x plus 3. So there's our top equation, and we might as well graph it right now on number 1. So it crosses at 3. From that point, I go up 2 over 1, and I will be off the graph, so I need to use that slope pattern backwards. Down 2 over 1 in the opposite direction, down 2 over 1 in the opposite direction, and so on. And this is an equation, it's not an inequality, so I know it's a solid line. I don't have to shade anything. That's my line that represents all my answers to this top equation in red. Now we're going to graph the bottom equation in blue. And in order to do that, I need to get y by itself, so I divide by negative 3, divide by negative 3, divide by negative 3. So I will have y equaling 2x, minus 1. Now if I graph that one, it crosses at negative 1, and I do go up 2 over 1, up 2 over 1. And I could use that pattern backwards of down 2 over 1 in the opposite direction. Now, this blue line does represent every single answer that exists to this blue equation over here, the bottom equation that is. And I am looking for that point that they share. But what about these two lines? They're parallel, which means that they don't cross. That means that they don't have a point in common. They don't share any points. So what should my answer be to number 1? No solution. Okay. Infinitely many solutions would be when your line lands right on top of the other line. Then you'd have an infinite amount of points that they share. Okay. So I'm letting you know all these 3 that we're about to do, they all end up being special cases. This one's no solution. We're going to have one that's like infinitely many solutions, and maybe another one that's no solution again. But for sure, on tomorrow's test, I'll actually have at least one where they do intersect. They do have one point that they share. There is a solution, okay? Let's go to number 2. It says solve the rest any way you like. So you do want to combine the lines to get a variable to cancel, and it's up to you on your decision if you want the x's to cancel or the y's to cancel. If you say y's, well, you'd have to multiply that bottom equation by 2. So the top equation is going to stay the same. Let me write it right here. Hold on a second. And the bottom equation, you multiply by 2, and you'll get a negative 4x, you'll get a positive 2y, and you'll get a negative 10. Now we're ready to combine those lines and eliminate the y's that I wanted to eliminate. And notice the y's eliminate, but then again, so do the x's, and so do the numbers. So that means I have an equal sign here that just came down, but there's nothing on the left side and there's nothing on the right side. So right there, 0 equals 0. What do you guys say about 0 equals 0? Infinitely many solutions. The reason why this top equation completely canceled out with the bottom equation is because it's really the same equation. Right? It's an identical equation. If I were to graph this, if I were to change it to y equals mx plus b and graph this one, change to y equals mx plus b, if I were to graph it, it'd be the same exact line, which means that they have an infinite amount of points in common. And this is why we say IMS, infinitely many solutions. So on your answer sheet over here, or answer column, IMS is what I'm looking for, right? Let's do number 3. Number 3, again, you want to make a decision of whether canceling out x's or y's. But again, it doesn't matter which one you go with, and the x's and the y's end up canceling out. So let's say I wanted to cancel out x's, I'd have to multiply it by 3. The top one's going to stay the same. So let me rewrite the top one right here. And that bottom one, after multiplying it by 3, I'll get a negative 6x with a positive 9y with a positive 12. And again, my intentions were to cancel out x's. However, the x's did eliminate, but the y's also eliminated, and the 12's do not eliminate. 12 plus 12 is 24. So you really have 0 equaling 24, which we know is impossible. So you should write this symbol or write out the words no solution. It's up to you, whatever you want. No solution. Okay, so next part of the test says use the following to answer, or use the following answer options to respond to questions 4 through 6. So they want you to, broccoli. They want you to classify number 1 above. So is number 1 above consistent dependent, inconsistent independent? This is not even real, guys. Inconsistent independent, that doesn't even make sense, right? Consistent independent, or obviously definitely not broccoli. So the way to get an understanding for this would be to look at the wall right there, and on the wall it shows the 3 options that you truly have. Consistent means that you either have one answer or infinite answers. Inconsistent means that they're parallel, there is no answers. So you have one of these 3 options: consistent independent, consistent dependent, or inconsistent. So when I ask you to classify number 1 above, we know that number one we have parallel lines in this case. So if they're parallel, that means that they had no solution. The classification of it would be an inconsistent system. So everybody would write down inconsistent. Actually, that would be option B. So everybody put option B for number 4. Now on tomorrow's test, of course, I have to change things around. Maybe I'll put the consistent independent as option A, consistent dependent as option B. So just make sure you pay attention. It's not going to be the exact same thing. Anyway, classifying number 2. Number 2, when we look at number 2, we ended up with infinitely many solutions. Why is that? I explained that the reason why they both canceled out is because they were really the same exact equation. If you were to graph them, they'd land right on top of each other. So which one would describe the ones that land right on top of each other? A consistent dependent system. So that's a classification: consistent dependent. And consistent dependent on our multiple choice answers would be option A. So let's all put option A right there. And the last one, classify number 3. Again, no solution. That visually would mean that they don't cross, and that would be an inconsistent system, so it would be B again. All right, so number 7 and 8, it's 2 points, because you have to actually do 2 things: graph this above inequality and graph the below inequality. If you have a highlighter, that'd be great to represent your answer of the overlap area highlighted. So let's graph the top one in red. If you have different colored pens, it's great. If not, it's all good. It crosses at -2. It does go up 1, 2, 3 over 2. And you could continue to go up 3 over 2. And you could use that pattern backwards. You'll be off the graph though. But anyways, this is, before I draw my line, I need to know if it's going to be a solid line or a dotted line. Dotted. Okay, so let's put dots between our dots, or dashes between our dots. Okay, anyway, now I need to either shade in above this red dotted line or below this red dotted line. If I wanted to, I could test the point 0, 0, which would mean if I'd have to plug in 0 for x and 0 for y, then it would say 0 is less than 0 minus 2. That's 0 is less than negative 2, and 0 is not less than negative 2. 0 is greater than negative 2, so I would not be shading in this above side. I'd be shading in the below side. The shortcut is simply this. If y is by itself, you could look at that less than symbol and say, oh, I'm going to shade below. Less than would be below, greater than would be above. So I need to shade below that red line. So lightly shade, okay? And now let's ignore that red dotted line and the shade and go to this bottom inequality and go on blue. This one crosses at the same location, negative 2, but I go up 1 over 1 instead. Up 1 over 1, up 1 over 1, up 1 over 1. This is kind of weird. Let's go with that pattern backwards. And this is a solid line because there's a solid line underneath the inequality. So I need to do a solid line right through those dots. And now I need to shade in either above the blue solid line or below the blue solid line. With that shortcut, what would you say, above or below? Above, okay. So when we shade in above the blue solid line, above, now what you really want to represent is the overlap piece, and this is kind of weird right here. It's this overlap piece. It's a really little tiny slice. It's like if you got a slice of pizza but you're on a diet. Super thin, right? And of course on the upper part it's dotted up here. And on the bottom part, that's definitely solid. So that's the overlap piece. That's what you really want to show, okay? Time for the most challenging part of the test tomorrow. We need to, this whole bottom half of this front page, you're going to have one single 3x3 system right here. Where am I going to select them from? From the homework or from the problems we did in class. There was a total of 10 questions that we did in class, 4 of which came from this yellow homework that we did, right? Maybe I picked that one. Maybe I picked this one. Who knows, right? But I am using 3 of the 10 that we did. We also did another 5 questions from, this is page 165 in our book. This is a teacher edition. It has all the answers right here. But I mean, for example, we did number 1. That was that interesting one where the third equation only had 2 variables in it, right? So think like a teacher, like which ones would he pick? And go ahead and pick from those, or maybe you want to also pick from the notes themselves that had a nice, beautiful first example that we did. Every single 3x3 system that we solved, it's recorded and uploaded. So, you know, I wouldn't pick the easiest ones. What's the point of that? I'd go and see which ones were more challenging to you and practice those challenging ones just in case I pick the challenging ones. Obviously the easy ones, if I pick the easy ones, then you'll be good. So you need to pick 3 of them, put one right here. Let's flip to the back side. And on the back side, you have to pick another 2, so it's a total of 3. So right here and down here. Wait a minute, the numbers are messed up, right? What should be right here instead of 9 through 11? Yeah, change that to a 12 to 14 and change this other one to a 15 to 17. There are 3 points each because they take so long. And then once you get through those 3 challenging systems of equations that you solve using linear combinations, we're going to have this last final section, which is review questions in an attempt to start getting you prepared for the midterm that we're having soon. So we have review questions, and some of us will be happy about this because they're pretty easy, and some of us will be irritated, kind of like that shoe rubbing the desk right there. What? We have to do it. What was that? Yeah, we have to do these. This is not extra credit. This is review questions, right? So question 18, state the vertex. That's pretty easy, right? What's the vertex here of this parabola? 1 and 4. So ladies and gentlemen, we might as well jot down some notes here. The vertex form equation is y equals a parentheses x minus h squared plus k. That's your vertex form equation. And you know, it's the same thing for an absolute value function. Pretty much any function has this format where your h is always going to be inside parentheses or some type of like absolute value with x, and it's being subtracted from x, which means that we always think opposite on h. You're going to think opposite on h. You're going to take k for what it is because it says plus k. So whatever you see, that'll be your k value. And that'll be your highest or lowest point. And it doesn't matter if it's an absolute value or a parabola. Your hk is your highest or lowest point, your most important point. Anyway, on number 18, they want us to state the vertex. So even though you need to transfer your answers to the front side, let's just write it right here. The vertex is, for number 18, +1, -4. So that's a really easy question. There's not much thought to it. If you understand it, you'll be able to answer it like in 5 seconds, right? Or less. Let's move on to the next one. 19. Which of the following produces a V-like graph that opens down and is narrower than its parent graph? Okay, well, C is the correct answer. Now let's just go through the different options because I might not ask for a V-like graph. Maybe I ask for a U-shaped curve, right? Which would be a parabola, a square, right? Or maybe instead of narrower, I say wider, right? So it all depends. I'm going to be changing it up, but this is like something that you need to know on these review questions on the test and also on the midterm that we're taking next week. So when we're saying a V-like graph, we're talking about an absolute value function. The absolute value functions end up producing some type of V, right? Anything squared ends up producing a parabola, which is a U-shaped curve. So if I say which of the following is a V-like graph, it can't be this one. That's a parabola. That's a parabola. This is the only one that it could possibly be. And the A value is negative, which means that it opens down. And the A value is also further away from 0, which means that it's a vertical stretch, which means that it's narrower, which means that that is the correct answer for number 19. Now, if I would have thrown in the word wider instead of narrower, then it would be none of these, right? Because the parent graph is the A value of 1, and in order for it to be wider, I would need a value closer to 0. This one's wider, but it's not a V. It's a parabola, right? Anyway, number 20, this is just a basic, do you know how to solve, right? So how do you solve an equation or an inequality? You just simplify, which means distributive property and combining like terms. After simplifying, try to get x by itself on one side. So let's distribute first before combining like terms. You multiply first before adding and subtracting. So -5 times x is -5x. -5 times -3 is +15. Bring down the 4x. After that, after distributing, you could combine the terms that are alike. We have a -4x minus a 5x. That is a -1x. Bring down the +15. That's as far as we could go on the left side of this inequality. I did say inequality because it's not an equal sign, it's a greater than symbol. Let's bring down that greater than symbol, put it right here. And let's also do the same to the right side of this inequality. Let's distribute. So 3 times x is 3x. 3 times 1 is 3. And then and then we bring down the +4. I almost distributed the 3 to the 4. That would be totally incorrect. Anyway, we have those 3 terms on the right. We could now combine the like terms. The 3 plus 4 is 7. So we really end up with 3x plus 7 on the right side. And now let's get x by itself on one side. The problem is we have x's on both sides. So I recommend moving the x to the left, okay? Because if you move the x to the right, you're going to have to flip the whole thing anyway. So let's move the x to the left by subtracting 3x, subtracting 3x. Our new inequality reads -4x plus 15 is greater than 7. My next step would be to subtract 15, subtract 15. We end up with -4x. This cancels out, is greater than -8. Now my final step is to do what? Divide by -4, divide by -4, and yes, we need to flip the inequality symbol. It would be really sad if we get this far and say that x is greater than 2. It's not greater than 2, it's less than 2. Because we're dividing by a negative, we have to flip this inequality into a less than. So there's your final answer right there. In a nutshell, this is the test, right? The only thing you need to do right now is go back to your homework or your notes or the videos, whatever you want, and pick 3 challenging 3x3 systems. Put one right there, put one right there, and do one on the front side, bottom half, and you should be ready to ace that test tomorrow.